All right. All right, let's do it. Let's do it. It's 5:58. Hey, I'm Eric. I'm making a game. It's called The God Killer. It's a game about one woman's battle with the most powerful person in her universe, a god. And actually, technically, she's not a woman, but that takes a lot of explanation. Here, let me update on my little doodads. It has been not 92 days, but 93. You're going to see it change up in the top right-hand corner. Days where I've made progress every single fucking day. Every damn day. On this game. So 93 days straight, and I have gone and done that when I was tired AF. No reason to abbreviate as fuck. It just takes the same amount of time to say it. When I was tired as fuck yesterday, I was tired as fuck. Let me fix up the date. Today, I'm not tired. I'm rested. Full recovery. And it wasn't hard to get there. Okay, what am I working on today? I'm going to write some code that I wanted to write for a long time. It is what's the way to put it? I'm like typing out the thing that it is, and I haven't quite given it a name yet. It's I wish I had it in real life. Actually, this thing, like not in code. It's audio interruption point calculation. That sounds terrible. There's got to be a better. Let's see what I'm trying to do instead of making it now. Figuring out how to interrupt dialogue optimally with an exclamation mark, because I am excited, because I've had thoughts on this for a long time. I'm sure somebody else has done this before, but I don't think it's a common technique. I'm going to show like what I'm actually trying to accomplish here. This may take me more than one session, I'll admit, but I'll try to break it out so I've got at least one goal for this session that I can achieve. So imagine, if you will. In fact, you don't even have to imagine, because I'm going to play it for you. I'm going to play it. So let me take out a bunch of extra stuff that's in this audio composition. All these things, these horizontal bars, they're individual tracks. I'm just going to make it really simple to look at and understand. So I'll take out all these background special. I've had like an audio drama thing that this all played into. So let's say that we've got a line like this is playing in the game.
People like you, you're worth nothing. You just push your way to the front, past others that would do your job better. That's all you know how to do. People like you are why we lost this war.
Okay, so that's a long line delivered by a talented actor, Atticus Wyman, and I recorded that with him a long while back. I say long line. It's not long in some context, but in the context of a game, it's very long. And I hate cutscenes. I hate like taking control away from the player and making them sit there and wait while some part of the story that I'm presuming is supposed to be important enough to them to wait is played out, and they're just thinking the whole time, can this cutscene be fucking over? I just want to get back to playing the game. So I don't want to be an absolutist, but there's a pretty good chance that this game will have 0 cutscenes in it. But it will be chock full of dialogue. It's going to have plenty of dialogue. And I want it to be a significant story, and I want somebody to be able to start talking like this.
People like you, you're worth.
And be interrupted midway through. So let me play an example of an interruption.
People like me?
All right. So imagine, you know, it would be a better example for the game that if there was like some special event that was being triggered. Like, I don't have the audio for it, but just imagine like, I don't know, you walk to one side of the room, your character does, and then it's the appropriate time to interrupt. And if we were interrupting this audio with this other clip, say this green clip is the player triggered clip. You walk to one side of the room and suddenly your character has something to say. It should be able to interrupt this speech here. So he's going,
people like you.
here would be a great place to interrupt the speech because the audio, the amplitude of it all went down to 0. You can see, let me see if I can just make this a little bit larger, a little bit larger now, a little bit larger. So you can see here in this, you know, these peaks and valleys. Well, here in the valley where the amplitude went down to close to 0, silence, that would be a perfect time to interrupt character. So I could say programmatically, by analyzing the samples from the audio file, pardon me, just checking on one other thing real quick. Just checking. Okay, so in the audio file, I could say, here's a good place to interrupt. And I could stop this audio, the first audio from playing, and I could start playing the second audio. I could do it right there. Well, I won't even try to adjust it how I know is a nice way. First I'll do it in a programmatic way. I'll say this point where the audio went to 0, that's where I'll start playing the interrupting audio, which my algorithm has no knowledge of the content of either of these except for the raw sample data and the amplitude at any point along there. So here it would sound like this.
People like you? People like me?
And this is maybe not that great of a contrived example because this audio is sort of playing into the same conversation. Let me just see if I can find one that's a little more representative. Something that has nothing to do with what the guy's talking about.
Oh, you and I will be the martyrs to inspire the masses?
So let's say it's this audio here, which is less to do with what he was talking about. So it's a better example of an interruption. You and I will be the martyrs. He's going to break in with that. Like, he just burst into the room with that announcement. Because it's got to, that's what these interruptions are like. So it's like,
people like you?
You and I will be the martyrs to inspire the masses?
or I just don't have the right audio right here, but like imagine him running, everybody out of the room. Something a little more urgent, right? Some kind of interruption. Or something that was on his mind that had nothing to do with the first characters. Okay, so I already have the dialogue selection code in place that will let this character, the interrupted character, resume the conversation at the same point where he was interrupted, but with an alternate line which leads back into the same thought. Kind of like, as I was saying, people like you. You know, so we would have version 1 of this line, the normal uninterrupted one starts out.
People like you.
And then goes on to say some other stuff over here. Okay? But then, like, if that gets interrupted, there's an alternate version which is like, as I was saying, people like you. Okay? So after this interruption, we can go back to that other kind of alternate version of the same line. Okay. So that part is done. The part that is not done is the selection of this interruption point and stopping the audio exactly at that interruption point. And there's one other edge case, which is, suppose this guy is talking. Let's take this other section of audio down here, which is a little more frenetic.
You just push your way to the front, past others that would do your job better.
So even here, there are plenty of places where it goes down to 0, but I was thinking of a case where someone's talking quite fast, and maybe they're like a drawling sort of person. I had a character called Arky that would say things like, Mithra Bodkin, you've taken too many steps in the wrong direction. And there's no low audio point in all of that because the way the character speaks, the amplitude is always up a little bit. That at the end of each syllable. Whereas Atticus, in his performance here, leaves me plenty of places to select an interruption point. Almost after every word.
People
Could stop there.
like
Or after like.
you.
So in the edge case where somebody is just going on and on, or they're talking really fast, people like you, blah, 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 then I need some kind of it's like a escape route from that. So I can say there's a maximum duration I'm willing to wait, and if I can't get a clear amplitude down to 0 or some close to 0 threshold, the ideal threshold, I will pick the lowest point within that range of audio, and I will dampen the audio kind of fast right in the middle. So here's what it would sound like. So imagine like I couldn't find a break point in all of this. Let me go to the part where it's talking a little bit faster.
You just push your way to the front.
Okay, so here I would take, say it was right here that I decided this was the lowest point, and I had to like cut right in the middle of it. That was like my best chance for interrupting. So I would cut right there, and then I would fade out real fast, and I can pick like in my algorithm like a fade time. Like it might be like a 1/20th of a second or something like that. So it would sound like,
you just push your way.
You and I will.
see, so if I had to interrupt him, it doesn't sound that bad. It's a little bit off. I'll play it again. You can hear it. So if I had to cut right in the middle of the audio, not gain a good interruption point.
You just push your way.
You and I will be the martyrs to.
Now, one thing I notice about these kind of things is if I bring in the interrupting line a little bit ahead, if I schedule it to be ahead of where this end is, it'll sound better. I know this from lots of editing. I'll play it for you.
You just push your way.
You and I will be the.
See, so I can get away with shit like that. I can get away with taking a performance where somebody didn't stop their talking, and I can kind of cheat a little bit, and I can manufacture the sound of an interruption. Done it a million times in editing audio, and now I want to do it with code. That's what this session is about. I'm going to set a goal for myself right now that I want to be able to locate a sample past the currently playing point in some audio where an interruption point can be. I won't do the more complicated stuff, or might have to bleed into another session of actually stopping the audio right in that place, or that edge case that I talked about just a moment ago where I have a fade out in the middle of the audio. I won't do that, but I will set a goal for myself to find the optimal interruption point in some audio. So that's what's next. That's what's going to start happening in just a second. This is one of those things where I really don't want to save this file. It would break my heart if I saved this file, so I'm going to close it, unsaved. No, do not save the changes before closing. Whew. Because it was perfect just how I had it. I didn't want to mess with it. Alright, let's get to coding. Let us write the code. And I didn't do a proper demo of yesterday's work, but it's okay. It was just like a little bug fix. So this project written in Unity. It's got walls that when you step close to them, they'll drop down. And so what I added yesterday in about an hour and a half of very tired work was the ability for, if it has some objects on top of that wall, before the wall drops, they will fall down along with the wall. Works like a champ. Put that in the done pile. Done with that. Done with that. Done with it. Done with that. Okay, true to my word, I'm going to demo it real fast. Real fast. It won't take long. It's going to take such a small amount of time. And then I will be able to say that I did do a demo. It does look just a little bit cool, so maybe it is worth demoing. And I say that, and the thing that will probably happen, my comeuppance, will be that Unity will crash. It has not been behaving well for me. I think of doing an upgrade as a starting point to that. But anyways, let me see. So I'm going to give this thing a touch. It fell down perfect. All the stuff on top of it also fell down. So my boxes, they continue to work. I noticed that the guide is incorrectly showing that you could step on top of a box and it should go underneath, but I can fix that. I can fix that later. So yeah, boxes, when they're stacked like this, you can push the bottom one and it lowers the stack. So there are some levels that I've got now where there's like really tall stacks of blocks, and they're really, really satisfying to manipulate. I demoed those on a much, much earlier episode. Okay, back to audio. That was the end of the demo. Just a quick one. I'm gonna hit unplay. Unplay. Will it not crash on me? Will it die in my arms? Unity. She loves me, she loves me not. Okay. I'm not gonna wait to see if it crashes. I'm just gonna move on to the audio. So I already have. Let me just close all my tabs. It's like clearing my mind, coming at it fresh. I just get rid of all those tabs. So where? I'm gonna close some folders. It's not procrastination. It's just a little bit of. It's like cracking your knuckles before you're about ready to get down to some actual legit work. Let's close a few of these. Let's close them. Let us simplify. Let us streamline. Let us have a pleasing array of items before us. There, now audio, that's the one I care about today. Not audio, dialogue, more specifically. Speech. Speech is the kind of the top level class for initiating some kind of talking, not just talking. I mean, not just the audio portion of it, but also like the subtitles. So I've got this top level say command where I say, here's the character, here's the line that I want them to say, and that line is also used to look up a specific audio file. Now it doesn't say it right away, it schedules it. So it creates a speech event and it schedules it, and it might be scheduling it to play immediately, but it doesn't play yet. It gets put in the speech events structure along with potentially some other audio or speech that's going to be played and shown before it. And it gets the audio clip if we have it. Okay. Adds it to the schedule. Now, silence all is called by the code that wants to interrupt speech. And I added this max time value, which is not currently being used in any way, because, let's see, because of the edge case that I was talking about, where when you scan through the audio, you might not find a place where it goes below a certain threshold. So I don't think this is going to be that hard. It's bad luck for me to say it, but what I want is not to stop right away. Let me kind of do a little comment design here. It's like don't write a whole document for your design, just add a few comments to think through things. So call func to find stopping point for the edge case of okay. It may also modify samples. I actually don't know if that's possible. Possible? If not, well, I have to set it might not be advisable. I mean, it sounds dangerous to me to modify the samples of a buffer while audio is being played back. It actually sounds dangerous. Like, I'm almost thinking like I'd be better off to, in that case, write some code that performs a manual decrease in volume. Or, you know what? I'm gonna say forget that. Okay, because I want it just sounds so dangerous to me that I don't feel like I'll ever be able to trust that it was the correct way to do it. So if anything is going wrong in my project, like right now, I've got Unity crashing on me, I'm always going to be second guessing that code to think, was that a correct thing to do? Or if I go cross-platform, suddenly it stops working, I'll be second guessing that code. So let's just assume if no silence, if no silence threshold point in wave samples, add params to speech event for fading out volume. So I can always just set the volume on the audio source on each update frame. I can just fade it out that way. That's not a bad solution at all, as far as I know. Okay, and then let's see, we'll detail that. Okay, so the other part is that if I find a stopping point in update, check for so set end time based on stopping point. So that will change the audio change where the scheduling where the scheduling detects the end of the speech. Okay, in update, This is what gets called repeatedly. It's always looking at the speech events in the schedule. Speech events schedule I've been using interchangeably. I'll start calling them speech events. An update. If a speech event is past its end time, but audio still playing, then stop the audio. Then audio source stop. Okay. And if speech event inside fade interval as specified for this no silence threshold point, then apply fade to volume. Oh man, I really think this is going to work. Okay, to find a stopping point, because this is where the cleverness is right here. What is this function going to be called? Let's see. Let's say find best interruption point, best speech interruption time. See, this is the thing I said, wouldn't it be wonderful to have this in real life where you just when someone's talking, you just kind of instinctively know that I'm going to interrupt them right now. I think I'm getting better at it, but it's been so many years to just kind of get sort of okay at it. All these different rules to it. Like if there's someone who never ever talks and they're talking, don't interrupt them. It's their time. It's their time to make their point. Just listen to them. Just let them talk. Give them 10 minutes. But if there's someone that always talk, I'm not talking about justice. There's a little bit of justice in it. There's somebody that they're always like blah 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 blah, and nobody else can get a word in edgewise. It's okay to push in a little bit. These are my rules that I've kind of formed. But usually the people that talk a lot, sometimes they're just a little bit better than you think they'll be at receiving an interruption, as long as you don't do it all the time. This is my whole theory about it. But anyways, I'm getting way off from the code. I'm just laying my personal theories about life intrude too much here. But there are all kinds of strategies for interrupting people. Actually, they might even apply to this code. I might have to use some of those rules. Actually, I already have. You can find that in the other interruption code that I wrote. Okay, so you find the best speech interruption time, and for that you're going to need the speech event. Speech event has got a whole bunch of stuff in it. I could break out just the things I need out of it. Yeah, that might be more useful, just as an exercise. So I need the audio clip, because that's going to have all the samples in it. I need the start time, the end time. I don't need all that. I need elapsed time. So the amount of time that's elapsed inside of this clip. But before I can do that, I need to identify every clip that's currently playing. So there's another function, which is find all currently playing speech. Bam bam. Speech events. And I guess I'll continue using time.time as sort of a global variable instead of passing it along. I don't think it's that important to pass in the time. And that will return an array of speech events that match the criteria. I might even it'd be better though, instead of returning an array. I know that's nice and clean and tight, but it also allocates like a new piece of memory right there. I don't want to allocate memory if I don't have to. So I can have a loop through for every speech event. If it's currently playing, then find the best speech interruption time. Okay, what is this going to return or do? It's going to so I need two things from it though. I need the interruption time. And then I also want to know, I kind of hate having to have like an extra param here. Is fade needed? Okay, another thing I need to pass into this is max time. That's the maximum amount of time I want to wait for everyone to shut up. For everyone to shut up. I don't want to wait 5 minutes maybe. I want to wait 5 seconds. No, it'd be less than that. It'll tend to be like a tenth of a second or a quarter of a second. Man, I got really man, let's just move this out of the function. Alright, so that's pretty good. I think this all goes up here. Let me design this function a little bit better. Favorite kind of function, a static function. Whew, though arguably I've been abusing it recently. Since I'm already in the speech module, I'm okay to take out the word speech. Have some implied context here. The speech class, I mean not module, that's JavaScript. Okay, so audio clip, elapsed time, max time, outpool is fade needed. Now, I might be better served to just pass in the speech event and then update the speech event. Although I like the clear contract of this, I feel like it's going to be simple code overall. So let me think of this as update speech event for interruption. So the idea is I'm going to use parameters inside of the speech event to describe what's got to happen, and also use it to output any changes that are needed to the speech event, which would enact the interruption in the update loop, which comes later. So let's call this ref speech event. That's a much cleaner signature. It is a little bit hand wavy as far as the contract. I did like the simplicity of that earlier contract, but it's not really that simple because there would be a bunch of calling code that would, yeah, anyways. This is going to be fine. It's going to be just fine. So some of the concepts I had, I can pull over from here. Elapsed equals time minus speech event start. What did I do? Oh. Got start time. Okay. Now I'm just gonna assert that I passed in something that's actually interruptible. So let's call elapsed. A clearer way to express this is that current time is greater than or equal to start time, and it's less than or equal to end time. Okay. So I'm going to check for a real trivial case, which is... No, I take it back. Never mind. Okay, so I got to get the samples now. Got to get the samples. Samples. Unity. Audio clip. Give me the documentation for audio clip. It's the converse of what I wanted. Not set data, but get data. Again, I'm thinking of like memory allocation and how it could kind of screw me. Because I don't want to be allocating and deallocating a whole bunch of memory all the time. That leads to garbage collection, which leads to frame stutters. So I don't know if get data is going to do that kind of allocation, or if it's going to be an expensive operation. I've got all my audio clips there. In case somebody's following along the docs, I'll make this a little bit larger for you. It's actually kind of nice for me too. I think it's because I need a new prescription on my glasses, and my old man eyes are beginning their descent into weakness. Okay, so one option I've got. It's nice here too. I can see really clearly how I'm going to get the samples and work with them. It's just at this point memory allocation I'm thinking of. So one option I've got is I can allocate the sample array one time inside of my speech events structure. And that would mean, if I was going to do that type of allocation, that I'd have to set a maximum value. I have to set a maximum value for the samples. Another thing I could do, might be better, is so at load time, when all the samples load in, it all happens at one time. It happens before the code that I started writing here. At load time, I could analyze each audio clip, the samples in it, to find all the interruption points, store the interruption points. And then I wouldn't even mind using a dynamic array for that, or a dynamic structure for that, because I would do it one time when the clips are loaded. For that, I would have to add a little bit of a container structure. So I'd load in an audio clip, but instead of being an audio clip, it would be like a clip or something, or like a God Killer clip, or it'd be my special clip that inside of it has an audio clip, but also some data describing the audio clip that's useful to me, including like the silence points or interruption points. I'm thinking about the benefits of either solution. It's kind of like I would incur a definite cost, processing cost, on every single WAV file that's loaded by analyzing all of them at load time, even if they weren't actually interrupted. I think most of the time these clips won't be interrupted. So it seems to me that I'm probably better off doing an evaluation for interruption points at the time that I want to interrupt. It's not that expensive of an operation. It wouldn't happen that often. If it is expensive, I'll be able to tell. I'll be able to see that it is expensive, and I can refactor it at that point. It's also easier code to write. The one thing I will have to do with that second approach that's a little bit extra work is allocating these buffers to copy samples into at one time during load time. It will take up extra memory this way, I think, because I'll need to say, okay, there's a maximum size for any sample, any individual sample. I might set it at 10 seconds or 5 seconds maybe, and that'll be a certain sample count based on the frequency that's used for writing the samples. I only have one channel, everything's pushed to mono from stereo. So I'll incur some memory cost, but even before I do that, should I just write the code that does it the simple way that I know does Alex and de-Alex too much? I think not, because I don't want to forget about it. I don't want to like talk myself into it working fine and then later on have to come back to it. I usually don't optimize prematurely except when it comes to things that I think can lead to really pernicious, difficult to solve problems. I'd rather get it right while it's fresh in my mind. Okay, so the approach is at load time, create max sized buffers to receive samples from audio clip. What was it called? Get data. Okay. Okay, then I have to copy from the audio clip into that buffer. Okay, so if there's another real simple case I should check for here. If there's no audio clip, if not, speech event. Audio clip. I can't do it C style. It's got to be not equal null. Then what do I want to do? I want to just adjust the end time. Equals, it's going to be whichever of these two is smaller. Now plus max time. So or no, I don't even have to do that. Just say it's going to end now, because in this case there's no audio to actually interrupt. There's just a subtitle, and this is a weird developer case anyways, so it's not very important. So go with that and just return. So that one's done. Handle case where no audio is available. This is not quite ready to be an error I care about, but I'll just put something in to later make it an error. Now I can check for that elsewhere. Never mind. Okay, so then I need to go over here and choose so it'd be nice if there was a constant that was already there. Basically, I want I think there is. I think there is one. audio clip frequency. That one. Just give me just a nice constant. It's already there. That would be my preference. Okay, so I think I already got that in, let's see, WAVSAV. No. Speech recorder. There we go. So let me put these in some constants that are shared. Let's call this I suppose I just make those constants part of speech. That'd be just fine. Okay, so let's take these. Let me call this silence threshold. I can reuse it. I can make it more convincing. Never mind. These exact constants are actually what I need to use. So I'll take them, I'll put them inside a different class. It's more general, my big old speech class. Max buffer length. I like that. I like that just fine. Oh, let's see. It's going to be speech. Let's say audio. Sample frequency. Max sample buffer. No, it's not samples there. It's max audio length. Audio sound threshold. Let's call this audio frequency. Okay, there we go. Reusable, refactored. Okay. execute. Okay, so then speech events. I want to say for any event, it's going to have, let's see, max sample count. It's going to be this frequency, that one right there, times the length of the audio. What are you complaining about? Yeah. Bullshit constants. It's like, why even use a constant? Okay. So that is what these buffers are going to have in them. So I need to have float samples, max sample count. Then, since I can't use the array to tell like how many samples in it, I need an extra value to say what's actually in there. What? That makes sense though. I keep reverting back to C-style declarations, even though I haven't written any C code in 10 years, 15, something like that. Okay, so that'll initialize that. That means I now have a buffer associated with each speech event. They will get overwritten all the time. So I won't perform the copy until I actually know I need it, but it'll be there. The sample count may not be important because, yeah, it won't be. It'll only be some memory they'll have available to me, and I'll know inside of the function that's operating in it how many samples are there. So might as well put this off over with the other constants. Let's call this speech. You can hear the American national anthem in the background. That would definitely be a bad error. Audio clip sample count exceeds Sounds funny to say an interruption was canceled, because an interruption is already a kind of cancellation. So the interruption was interrupted. Okay. So then let's copy them. Speech, event, clip, get data. So one thing that is encouraging is it takes an array that passes into it, so it's not going to be allocating anything. Like, otherwise they could have just returned an array. I do have an opportunity here to do less work. It's kind of a bad thing to name that samples, because there's something else called samples, which is not meaning the same thing. The other samples is a count of samples. This we'll call a sample buffer to avoid confusion. So if I pass that in, it's going to come back with stuff in it. But the offset, that's my opportunity. I don't have to copy every single thing there. I can just copy over what's remaining from the current time. So let me calc the offset. Float offset equals. I'm going to leave that logic up there, even though it's a little too stringent. In theory, with an offset that's in the middle, I'd have less to copy. So the offset is going to be the elapsed time in seconds times frequency. And I'm going to check another thing. I'm going to check that the format of the audio clip matches what I expect. It also seems like I'm checking this audio clip variable a lot, so let's assign it to a variable. Then I can just shorten a lot of code, and presumably it might even be a performance enhancing thing. Okay, let's check that this thing is what we expect it to be. Because if I'm wrong, then a lot of calculations are going to be wrong beneath. Number of channels. It should always be friggin' mono, because I did a forced to mono type thing. So those two things, along with the length and time, determine the number of samples. Okay, frequency is the number of call it amplitude peaks inside of 1 second. So that's hertz, number of repetitions within 1 second, or number of samples, you could say. So the offset is going to be elapsed times the audio frequency, and we've got to convert that into an int. Which would be kind of iffy, but for this I think it's fine. I kind of don't like doing stuff with floating points and mixing it with ints. It's fine for this case though. Okay, so it gave me a bool. No, just trying to get it to. Okay, I want to see what the bool value is going to be. I think it's just if it's false, then it didn't work. But I want to know like what could make it fail. Probably if the array that was passed into it was insufficient in size. I think I want to add a little check here to make sure that I don't wrap around to the beginning. So they're saying if I set my offset longer than the clip length, it'll wrap around to the beginning. I could see like maybe with that floating point method doing something like that. So it's pretty good, but you did not describe the bool. Unity documenter. So I'm going to give you a 3. I'm going to report a problem on this page. Information is missing. I'm going to provide more information. Needs documentation on the return value. I assume bool of false means failure, but it would be good to know what possible conditions of failure are. It would also be nice to know if now I'm just being a punk. While you're getting me a glass of water, could you also bring me a little napkin folded 3 ways? Yeah, just being a punk. It's too easy to get persnickety when you have a technical mindset. Okay, so So now I've got the offset. I want to say the if. I'm not going to check the bool return on this. I don't know what I would do with it. Alright. So if the offset is greater than the number of samples, greater than equal the number of samples, we're done. Nothing else needed. I'm not actually going to set an interruption point. Offset is too close to end for any useful interruption. Floating point weirdness responsible for going past. I just don't trust floating point. I probably attribute too many strange things to floating point at this point, but I've been through some shit, I will tell you. Alright, so now I get to friggin' analyze samples. That's a dumb word. Find interruption point within samples. So I just go for 0 to, oh, here's the tricky part. I need to know the count. I guess it's not that tricky. It's just int sample count equals the total number of samples minus the offset. Is that right? That's right. That's right. Okay. So I want to do, I'm already writing this code. I want to do two things here. I want to find I want to find the best interruption point within the range of acceptable interruption time. If I find one that's below the silence threshold, immediately I stop and I say, good enough. This one we can interrupt at. If I don't find one below the silence threshold, then as I'm going through these samples, I want to have collected the quietest point. Now, I may not be doing this very well, I'm thinking now, because finding a sample that's at 0 inside of a high frequency set of samples does not mean you found a point of silence inside of that audio. It means that for the tiniest imperceptible sliver of time, way less than a millisecond, way less than a microsecond, maybe close to a microsecond actually, that little peak was at 0. Now if I yell, if I scream, ah, there's probably still inside of that scream there are samples that are at 0 if I recorded it. So there's another type of calculation that you can perform to get the loudness at a certain point. I've written code for this already. But before I lose my thread here with the larger set of logic, I want to just write a few notes here. Yeah, or actually write a little more code. So I need to find the stopping point, which is float stop I equals max time times audio frequency. And then this should be the smaller of two values. Okay, so it's either going to stop at the end of the whole friggin' audio file, audio buffer, sample buffer, or past the maximum amount of time we gave it to interrupt. It'll stop there. Okay, now I gotta go dig up that other code, which shouldn't be too hard. Actually, there's more than one Visual Studio. That's my problem. So now I'm in JavaScript code, and I'm just trying to remember. If I can just find this code, I can copy it across. It won't be hard. Clip value, cloud files, debalancer, file path, list text, phoneme, recorder. Wave, was that it? It was wave, wasn't it? Is silent frame. Oh yeah, RMS, that's it, that's what it is. And it said get frame RMS at a frame now. Okay. I had something where I loaded that in and calculated the RMS. There it is. Calc RMS from audio section. Oh yeah. So this is the code from JavaScript land that was doing the job, doing it well. I'll copy that over. And it occurs to me iterating over each sample is probably not going to be correct. It's got to be chunked up a bit for this RMS thing to work. Let's see. Okay. So let me think about this. So it's just write a quick utility function here based on the other code that works like a champ. Calc RMS from samples. Say basically the same thing. In fact, I'll even let the the variable names be very similar. Start read. End read. Float. Sample buffer. Okay. So and so it's just a way of usefully averaging out the loudness over a whole bunch of samples that are in samples are in a format where they have all those peaks and valleys to them. So if you've ever seen, here, I'll show you the audio. Now I can't, I already closed it. If you've ever seen audio up close and you see it's all those peaks and valleys, which is the air pressure increasing and decreasing around your ears eventually. Samples actually capture that level of detail. They're just a number that represents the amplitude, which is also like another way of saying air pressure. So like when the air pressure goes up to the top, it kind of corresponds with like the air pressure getting kind of higher around your ear, and when it goes down the other way to the bottom, air pressure gets lower around your ear. And those samples, they actually are measurements of air pressure differences. First, as they're detected around a microphone mechanism, and then later as they're reproduced by speakers. The little thump 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 thump. I don't know what it's called. It's like a little hammer in there, inside the speaker. This little magnetically controlled air poker that pushes out, pushes air, compresses it when an electric signal gets sent to it, and that speaker, it's just a thing that's batting on the air, really really fucking fast, and each hit of that speaker to the air is controlled by these samples. So if there's a sample and the value of it is max, it might be like 1F here in this calculation, that little speaker poker, that air beater, is just whoop all the way out. I think I might be oversimplifying it, but like all the different modern audio equipment type stuff might have kind of made this a simplistic explanation of it, but at least a device created this way would function. So anyways, so that's the magic of these samples. They're really that accurate, that corresponding to things in the physical world. But in order for me to say, well, how loud is it? How loud is this noise I'm hearing right now? I can't just grab one of those samples because it's too precise. I have to average out a section of them. And this RMS calculation is what performs that averaging. Okay. So total is going to be a float. Sample count for RMS, we'll call it 0. And it's kind of a dumb way that I've got it calculated above. I can see that now because I could just simply calculate it here as well instead of iterating inside. So inside of here, I keep on adding to this total. That multiplication with itself is a way of getting rid of the peaks and the valleys, or not getting rid of them, but representing them equally, so that if the air pressure got really low, it's kind of worth the same as far as loudness as if it had gotten really high. So if you square a number, it's going to always be a positive number. So it's a way of kind of correcting for that. I think I've got something here that says that if there were no samples, I'm just going to return 0. But I didn't have to wait to go through this whole iteration, because the sample count is just going to be end read minus start read. So I can just say at the top, I can just say, this is just really kind of simple. I don't know why I wrote it this way to begin with. If they're the same, there's nothing to look at, return 0. This is much better code. And let's put that evaluation up here. Okay, so down here I can be more simple. I can say return square root. Why the square root? Because we did this thing up above where we squared. So it's just kind of getting it back to a correct representative value of the average. So divided by, and I'll go ahead and do this calculation here. Yeah. So the sample count is just n minus start. And this, what were you expecting? Capital S. Okay. There, I just ported some JavaScript code to C#. I think it's going to work. I think it'll work the first time. So now I need to think about my chunking a little bit. And now that I'm thinking about the need to perform this extra calculation here, I might find out I do want to pre-calc this stuff, but I don't want to assume that quite yet. Computers are fast. They can do so much these days. So what would be a good chunk size on this? So I know that if I make it smaller, if I make it too small, it won't be representative and it'll be more work to calculate. If I make it too large, it will not stop at the right point. It'll be like a sloppy stop. So I think I want the chunk size to be the largest amount of time that is not really perceptible to you when you're listening to it. Like if I go da-da, and I tell you that's one time, I go da-da, I tell you that's another time, the time between those two dots. Do you notice the difference in those times? Da-da, da-da. Do you think they're exactly the same? I don't. I think they vary a little bit. So I know I can detect 1/10 of a second, because think about like 1, 2, 3, 4, 5, 7, 8, you can almost count to 10 verbally. Some people can that have good tongue muscles. So that's definitely a very detectable measure. But 1/100 of a second, like if you imagine what that would sound like to hear all the points of a second, divide up into hundredths. Like, of course, you have no hope of pronouncing a whole word like 1, 2, or 3 within a hundredth of a second. But even if it was just a little beep, and actually notes that you hear, they're starting to get into that range. So if I play, I bet you I can just say 100 hertz tone. I bet you, yeah. This can be, so that is a repetition that's so frequent that we don't even hear it as a repetition. It just becomes like a single continuous sound to our ears. Let me try 50 hertz tone. You know, I just feel like it's just gonna, okay. Here we might have a chance of hearing like individual clicks. Except it's so low. Well, I mean, here it's like so low though, but like, yeah, there's like no hope there actually. So what is the detectable, lowest frequency humans can hear? Okay, 20 hertz to 20 kilohertz. So interesting. It goes pretty fast. So 10 hertz is really literally 10 times a second. And I can almost go 1, 2, 3, 4, 5. I can almost count like out loud to 10. And then you go to 20 times per second. And it's like, but it's like, like it couldn't be like, because then that wouldn't be fast enough. So it is actually like, okay, I'm going to go 20 hertz. 20 hertz seems to me like a pretty good max chunking size. Alright. So let's call that definition is so coupled to what we're doing in here. I'm gonna let's say RMS sample. No, I can't reuse the word sample. RMS chunk size and it's going to complain about not using const the right way, but I'll start out this way. So it's going to be, the time will be 1 second divided by 20 hertz, and the number, so that'll be like the length of time, 1/20th of a second basically. And the number of samples we can expect to find inside of that is going to be our audio frequency again. And then it's going to complain that it's not a proper, okay, that too. 20F. And then you are complaining about that. So let's call this float. Let's call all of this stuff together after everything's calced and int Now you're complaining about const assignment? That's right. So C# with your fake, barely useful constants. Fuck you. You should have done it better. Because now I have to do this. I have to do this, and it's an embarrassment to the architects of C# that I have to write all this crap. I'll make it private though. RMS chunk samples. Always enjoy a more specific name up until I've written 50 characters of very specific name, and then that's too much. Okay, so where was I at? Alright, so I've got RMS chunk samples, and I want to check from the beginning of my buffer to the end I'll say minus RMS chunk samples. That's actually, I was already going to do something here called stop I, which runs with Popeye, and here I'm going to advance by this new constant that I love called RMS chunk samples. I'm going to do that, and this I need to recalc because it's going to be, yes, this thing here, but it's going to be minus RMS chunk samples plus 1. So here's my rationale. I don't want to go grab a really tiny RMS chunk right at the very end of this buffer because it might be too small to be representative. So I'm using this chunk size also as like a good safeguard against grabbing something too small that won't actually perform a good calculation. So if I set my stop I, which runs with Popeye, stop I the Sailor Man, to stop at least one chunk ahead of the end, then I'm going to be good. And it occurs to me I can optimize this a little bit more because this max time thing might be in the middle of the sample, middle of the buffer, so I can instead just remove this from the sample count here. Whichever one of these is smaller, that will be the stopping point. Okay. So next, I'm going to get my RMS, and I want to track smallest RMS. And I'll give it a value that is easy to beat. Easy to beat. And this stop by needs to be an int. Sample count on max times. Okay, so I'll change this to an int. Okay, so int smallest I. So then we get the RMS for this particular place. So this is going to be calc. Come on, I just wrote this. What's it called? calc RMS from samples. I plus the samples. Let me just buffer overrun on this. Okay. And then the sample buffer. What? Oh, yeah, that's right. Speech event. That's got it. Okay. So that should do that, right? Okay. So float RMS equals that. And if we're less than the threshold, we're done, baby. If RMS is less than the audio silence threshold. I don't know if that threshold, which works so well on the speech recorder, is going to be the same threshold that should be used for detecting an interruption point. But for now, I'll use it. I'll see how it goes. I can split it out later if I have to. So if that's true, we're going to break. Okay. And then we say, then we say, if this is the smallest RMS we found so far, let's remember, we might come back to it. Hopefully we just drop below the silence threshold. Then we've got a definite, nice place to break. But maybe we don't. Maybe we're not that lucky. In that case, let's remember our best case for interrupting. This is like the friend who won't shut up at all, and he's just talking. You just wait for it till it gets a little bit quiet. Then you say, here's where I'm jumping in. Here's where I'm jumping in. Sometimes you gotta do that. Oh, okay. So down here, I know I exited the loop either because I found something below the silence threshold, or I didn't. I got all the way to the end of the section of samples that I wanted to analyze. One of those two things happened. Let's see. So if it's smaller than here's the thing that's bugging me. So it might be that the very last one that I check is the interruption point. So if that's the case, then I'm thinking let's retain it, because I need to be able to get a silence that's right at the very end too. So now I need to think about what changes to make to the speech event to enact an interruption later. Set interruption instructions in the speech event. Okay, so speech event end time is going to be smallest I times audio frequency. That's it. That's where we're going to end even if no, this isn't quite right. This isn't quite right. It's smallest I divided by audio frequency. Now what? Okay. Does this need to be? Sometimes it like does some kind of weird conversion to int. If I don't know. I probably didn't need to put that extra cast there. Okay. So in either case, whether it's a nice clean interruption or one where we got to kind of talk over the other person and hope they'll just kind of mute out. The end time will get set that way. But the other thing to check is if fade out's needed. Okay. And here I'm just going to say to do. In case where smallest I is where smallest RMS is greater than equal the audio silence threshold, a fade will be needed. Add instructions to speech event for setting volume at a start fade point 100% logarithmically to 0 at the end time. Okay. So that can be left in another pass. I might have some nice code here. It might be pretty good code. Like, I didn't cut corners along the way. So let me hook it in. I don't think it's gonna. I don't have enough here to properly test it all yet. But let me start hooking it in. Where's that silence? Oh, okay. So there will be no stopping like that. It's going to be something along those lines. I already have a thing here that says give me all the stuff that's playing right now. I feel like it might be more reliable for me to use the start and end. If I pass in bad start and end up here, it's just slightly wrong, it's going to throw an insertion. But I could just be a little more graceful about it, because this check would end up having to be moved down into the calling code anyways. So I wanted to say if it's outside the bounds, we'll just exit without doing anything. It's fine. Okay, and that lets me do max time and speech event. Jesus Christ. Okay. Really? I don't understand that. I don't understand that. Pass event equals speech event. Pass event. It's gonna make me mad if this works. Why? I can't use this because it's in the for each loop. What? What? Why? Why? God, stupid. Let me call it something better. Event to update. Okay. So then this other stuff I wrote in my big algorithm up here. This here. This part I need at a minimum. The rest here, I think I can delete. I remember the rest, or I implemented the rest. Okay, so I'll say if the event is past its end time, but the audio is still playing, just stop it. That's safe. I already have some code for that. So if then we say stop. It's time for you to be interrupted. So then, let's see. Stop. Okay. So let me think. How to test this well. Let me depart from code I have currently in the level controller that sets up speech, and set up some test speech. So where did I put this? Was it logic? Yep. So I'm going to set this to a new state. Testing. Interruption. So if the new zone, okay, I get it. So let's say that if, maybe not use the birth room, I'll use antechamber and lower room. So else if state equals testing interruption. So many things to say to you. I could go on forever and ever. Okay. Is that kind of a long thing for that guy to say? So whenever you go into the antechamber, God's going to go say that, and whenever you leave the antechamber, gonna shut God up. And we're gonna have M say shut the fuck up. Okay, this. Oh, max time. So let's start out at give it a quarter of a second. That seems like a good amount. Okay. So first I'm gonna try that. That was a lot of new code. Let's build it. Build it, baby. It's already debugging. When I finally get around to playing the stuff and doing the interruption, I don't want to just like listen to see what happens. It's just too much new code. It's actually a little bit dangerous. Like you can think it's all working right, and then there'll be something kind of subtle that needs to be attended to. So I'd rather not just run it and see if it all works that way. I want to debug through it. And I'm actually going to do the poor man's test coverage, which is setting breakpoints in all the different execution paths, and I may not try to go into all of them. Actually, these are error cases. They're not that important. I just want to make sure I get to everything. And this case is interesting. This case is also interesting. Alright. And then this also helps me if I get caught in a loop and I want to just see if execution makes it through all the way to the end, then I can hit play and it'll go through. So all that is there, waiting to be debugged. Unity seems to be on speaking terms with me. Let me take out this kind of temporary junk that was only here for fixing a bug. Okay, any day, any fucking day. Come on. Boom. Delete. Just ask him for delete. Delete. Just delete. Just delete. Delete. All I want is for you. Oh, you just take fucking forever. Delete you, delete you, delete you. And then pop wall. Go away. Okay. Thank you. And let's do a save. Haven't saved in a while. Okay. And let's wait for you to do something else that you think is necessary. Maybe it is. Probably is. It's just like, when are you ever done? When are you ever done? When are you going to be? Okay, cool. Let's go ahead and try it. There's no way this works on the first try. No way. 0.5% chance of it working on the first try. Oh, I don't have to make dinner. I scavenged from work tasty taco fixins. All I gotta do is like throw it in the oven for a little bit. Okay, so you should say something like Come on, I just wanted the subtitles to work. Oh, I gotta go into the next room. Oh, this thing won't come down until... Alright. Did you crash on me? God damn it. God damn it. Oh. Oh. Alright. I think this Friday on my non-streaming time, I'm gonna have to dig into this crashing thing a little bit more. I can alright, while it's doing that, yeah, nothing there. Sometimes I get like some good useful information in the editor log. The other one said something about anyways, I'll come back to it. Let me fix the thing that blocked me last time. This guy here. Make a temporary change. Lets me get to the room, so I can trigger that test code. Start up, have it start down, or just friggin' hide it. That's gonna be better. All right, then play. Now it's part of the night when my brain gets a little bit tired. Okay. So I walk down here, and God should start yapping. Okay. So I haven't recorded like the audio files for it, so they're not quite interruptible. At least not in the audio clip way that we just wrote. So here's the threshold. Shut the fuck up. Okay. Go back here. So many things. She comes down. No, it should interrupt there. Should interrupt there. Okay. Think about that. Shut the fuck up. Okay, that's one. I have so many things to say to you. I could go on forever and ever. That's two. So go down. Shut the fuck up. Go up. So many things to say to you. I could go on forever and ever. Okay. So I've got my two audios recorded. Once she went down, I expected for it to call silence all and trigger my breakpoints. Oh, but I lost my debugger connection. Okay, because Unity crashed. So let us stop. Hopefully it won't crash. Okay. Let's see what console log looks like. It's pretty benign. There's this one error that I've had for a long time. That one I might dig into as well while I'm looking for crash stuff. Okay, so let's run the debugger. I might have been able just to attach to the debugger while it was playing already. I've never tried that. I'm not sure if that works. It seems like it needs a debug build, but I don't know if the build that it makes by default is a debug build that has all the symbols in it that are required by the debugger. It would kind of make sense, because when you do like a proper build, a player build, you could take all that stuff out, so that might be a good default. Very low frame rate, but that's probably a broadcasting artifact. Shut the fuck up. That's so many things to say. Like you're going forever and ever. Oh, good. Okay. So now we are interrupting. Okay, so far so good. I'm undoing these breakpoints as I get through them. Looking, just kind of get the lay of the land here. The frequency is right. Well, it should be. Length 2.9 samples. Yeah, okay. Things look good. I have this inverted right here, so this is gonna make it so I can't get down to this logic. Cool. I know how to fix that. That's a real easy bug. So let's hit play. Stop it. Stop it. Stop it. Stop it. And while I'm at it, I'm going to turn off that maximize on play. I don't need it right now. I'm not trying to be dramatic. Oh man. I've got to get my project in order for that build time stuff. It's killing me. It's worse when I'm broadcasting though, that's the thing. Okay, so turn off, maximize on play. Okay, I should start rebuilding. Oh, I'm gonna go grab my phone, because I might have missed some important call or text. I'll be right back. Did I leave it up here? Did I leave my phone up here? Did I leave it up here? Where's my fucking phone? Where's my fucking phone? Where about? Where's my fucking phone? Got my phone. All right. I just want to accomplish one useful thing before the end of this session. That thing that I set out to do, to find the point inside of the wave audio which is best for interrupting. And I think I could do it. It might take me till like 8:30 or something like that, but I'm close. I think I'm close. The algorithm has got to be pretty close to right. The bones of the solution, I think, must be right. There's probably a few bugs to fix still. In a fucking slow-ass development environment. This is not a piece of shit machine. This is it's like a 3-year-old iMac. It's nice. So many things to say. Why you're going forever now? Okay. Shut the fuck up. There's so many things to say. Why you're going forever now? Okay. Breakpoint. Please go to the breakpoint. Just go to the breakpoint. Go to the breakpoint. Okay. Where are you at? Good. 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 All these are good. I'm going to undo them. Okay, so what do I expect the offset to be? Elapsed? What do I expect elapsed to be? Maybe at 1 point something? 1.18. Good. So the offset is going to be a number like 150,000, something like that. Oh, 52. So oh, okay, I was thinking 144. Okay, that makes more sense. That is right. Okay. Sample should be more than 40,000. Okay, that's cool. 130,000 means we're like 1/3 of the way through it, something like that. That seems a little large. There might be like a long tail of audio at the end, like from my fan that wasn't getting trimmed, but still within the range of reasonable values. Okay, so then I want to copy that to my buffer. What does my buffer start out with? What's it got? Zeros? Zeros. It's got zeros. Okay. Now what does it have in it? Has it got numbers of substance? It certainly does. It's got proper samples. Proper samples. Okay. So, max time is 0.25, and I want Stop By the Sailor Man to be with a lesser value of 11,000, or that it's going to be like 120,000 minus the size of one chunk sample. What is that size? It's something in the hundreds to low thousands. Yep, sample count. So I want to come back from 78. Okay, so it's going to be which of these two will it be? 11,000 versus, let's just tell. Okay, it was 11,000. That makes sense, actually. Okay, smallest RMS. So I go through, and here I'm pretty curious. So it's going to go to 0, 0 plus 11,000. Oh, 2,200 actually. And reading from the sample buffer. So let's go into there. That will not be true. Starting at 0, going to 2205. That's the chunk size. Okay. The first one might just be 0. No, I guess I had data right away. It kind of makes sense because it was trimmed. It was trimmed. So really small values so far. Let's see, this should be like 22,000 or 2,200. Okay, so RMS total. Okay. Whenever I set a breakpoint, well, I'm already running, it just doesn't do much for me. There we go. It actually kind of screws up things for me to track along with it. So what kind of RMS total? That's fine. So if divide that, it'll be some really small number. So this should be maybe immediately be below the silence threshold. Quite curious about that. So if I go like that, 0.015. What did I set the silence threshold to? 0.01. Okay, it's just a little bit above the silence threshold, and that's nice because in my trim code I was saying cut off anything below it. So it sort of makes sense that the start of my samples would be above that threshold. It also makes me think that the code that's in there for trimming, it might be a little bit screwy. Like it might need to do something more like what I'm doing with the RMS. Because I think it just looked at the samples. I don't think it did any kind of averaging. Alright, but I feel pretty good about my RMS function. It won't yet be true that it's below the silence threshold. It might be less than the smallest. I don't know. I think I went through one loop. No? Okay, cool. So smallest 0.02, and this one, okay, cool. The first one was originally set. The first chunk was originally the smallest, and now this second chunk is the smallest. Where is I now? I think it's at 20. Yep, that's where it's at. Cool. So far, so good. And I'm gonna let the run play. Okay, so this means to me that it broke through without going beneath the silence threshold at any point. At least in that section that I gave it. So the end time it's going to come up with is going to be 2205. Okay, it's occurring to me that this isn't the entire right calculation. It's actually going to cause a problem. So that's going to say stop 0.05 seconds, but from what? Relative to what? It should be relative to the start. Should be relative to the start. So this is incorrect, but it's close to being right. I'm going to take that off. And I'll hit play. Shut the fuck up. Unfortunately, I have to stop it and rebuild. So the end time should be now plus the index that I found for the interruption point. Because this index is measuring from now, looking at samples from now. Okay. So I would have liked to have seen the audio silence threshold met, but it is possible that within that quarter of a second that I gave it, it did not find anything that went below. That is possible. Okay. Let's save that and let's get a new build. Close. This next one is a candidate for success. This next one could be it. Ooh, what's this? Data longer than the audio clip. Oh, I gotta check into that. Data longer than the audio clip. So here I'm calling get data. So there, I'm so close on this. I think I'm really fucking close. So it's telling me that it had more data, even though I performed a check ahead to make sure that the number of samples it had was, I'm sorry, this is like way too small for anyone to be able to read this text down here, but basically it was saying, when I called get data, that there was not enough room in my buffer to copy all the samples. I find that cheeky. I find that unlikely, or somebody didn't hold up their end of the deal, because I checked, man. I checked. I've got the number of samples right here, according to you audio clip, and I said, is it the same as my maximum? Is it more than my maximum that I allocated in the buffer? If it is, I'll throw the error. I won't wait for you to throw the error. I'll take responsibility for it right here. That's what I'll do. I was ready, but that error message did not show. And then I called get data, and it got surly with me. It said, you don't got enough room, buddy. It tried to copy, failed. So I'm not getting that. I'm not getting that. Doesn't make sense. Huh. Didn't do it on the first run through. Did it do it on another run through? I saw the samples there in there too. It's so strange. Alright, I guess I gotta set the breakpoint back here. Just to make sure on this. Because I that's hard to let go because that might be a editor only check, like that safeguard that was there by Unity may not be present in the player code. I don't know how. I assume they have optimizations where they take stuff out that would prevent kind of debug errors in order to be more performant in the player. But I don't understand. I don't understand the cause of that error, because by my reckoning, I should have been good there, more than good. Maybe it's like a off by one type thing. I don't know. That's just weird. Okay. So many things to say. I could go on forever. Shut the fuck up. That's so many things to say. I could go on forever and ever. Okay. So here, how many samples you got from it? You've got 130,792. Is that more than my max? It's not even close. So if you complain for me down here that you don't got room for all the samples, then I'm going to be upset. Unity, I will be upset. Okay, so sample count. Start time 11 seconds, end time. Okay. Smallest I was 0. That's possible. Like the very first sample could have been. Yeah. This code is still not executing. Don't like that. What is this? The smallest RMS is this 0.00. That is below though. That is below. That's below the silence threshold, so it must have come through here. I just probably skipped past it. Oh, this is the other fucking thing about consts. Never mind. Never mind. I'm being stupid. It's getting late. Getting a little bit stupid. Alright. So if it said 0, it might have just been that the smallest sample was actually there at the very beginning. Since I do actually have a smallest RMS value that's reasonable, I think that's what happened. I think it did go through here. I think it went through there. Let's see what I ended up as. Can I know that? I ended it at 0. It must have braked out right here. Okay. Let me just hit play. So now Shut the fuck up. Where is it doing this? That array had a much larger capacity. Let me check this shit again. This time I won't go by the maximum audio sample count. I'll go by okay, let me check over here too. See, there, I'm initializing it there, but I'll double check. I'll double check, because this is weird. I gotta narrow it down. So let's go down to scene of the crime right here. So many things to say. You're going forever now. Okay. Here's my question. Sample buffer. God damn it, it's 441,000 elements in this thing. And this is the only place where this get data should be called in all of my source. So I know that it's complaining about this call right here. So I'm going to hit play. I'm going to go check console. There it is. Shut the fuck up. So I can't trust the results of whatever I'm doing until I understand that warning. But it's 8:30. God damn it, I hate ending without the progress. I hate ending without the progress, so I gotta push on this. I gotta push. And okay, Unity, get data. Okay, first I'll read the docs. Okay, so how many samples do you expect to get? Inside of data. I'm looking for something not obvious. So now, since I see no insights from the documentation or things that would tell me I'm doing something wrong in my usage, I'm going to take the error message. Wait, are they saying that the array I pass in needs to be the exact same size? Oh, that could be it. If so, that's really terrible in its own way. I'll explain why, but first I want to find out that's the case. So I'm trying to see if this fellow's situation matches my own. So he loaded in. This person is much more clueless than I am. So, is that specific text in there? No. Let me do the I really mean what I asked for query. This is like a you're off on your own kind of problem. So one person kind of said that he got an error like mine when he was doing something different. But that's not really helping me. And I don't see any other instance of someone getting the same error. So I'm going to try one thing. I don't like doing it, but I'll do it. I'll go ahead and fucking allocate some array right here. It's equal to the number of samples I expect to read. Okay, so let's say float sample buffer equals new float audio clip samples minus offset. Let's see. So if the offset was at 9, but yeah, that's okay. Cool. So then let's do this crappy thing. Delete GC. Okay. So let me try that just to see if I get that one warning to go away. It might be a benevolent warning too. But it's really hard to tell, and I don't know if there's anything that would ever make me feel good about seeing that message. It just feels like on some platform somewhere it's gonna like crash or, you know. Okay, waiting for Unity to start up. I'm going to test this out again. So if this fixes that warning, it would point me towards one of my other solutions, which was to calculate what I need to know at load time and store it at that time. Because what it would mean is that it's not a good choice to use those one-time allocated one-size-fits-all buffers, and that it's also not a good choice to dynamically allocate them. So I would be stuck with...
Shut the fuck up. That's so many things to say to you.
It worked!
Shut the fuck up.
Okay. So one thing didn't work well, but the basic gist of it, find the interruption point, did work. Okay.
That's so many things to say to you.
See, do you hear that?
Shut the fuck up.
So the shut the fuck up, the timing of it starting was not corrected. I understand why. It's okay. It's definitely okay. It's definitely easily fixable. But my goal for this session was achieved. Also, I got the stupid warning error message to go away, which will point me to like an optimization to be done later. But the goal of my session was to find programmatically the interruption point within the audio samples, and I did that.
That's so many things to say.
You hear that? I'll turn up the volume a little bit.
Fuck up.
So note that it doesn't cut out in the middle of like a syllable or something like that. It doesn't go, I have some, it doesn't go, and just suddenly truncate it right there. It finds the point where the volume dips down to 0. It stops it right there.
That's so many things to say to you. I hear go.
Yep.
Shut the fuck up. That's so many things to say to you. I could go on forever and ever. Shut the fuck up.
Okay.
That's so many things to say to you. I could go on forever.
Done. Session success. Mission accomplished. I would just shut this thing down. It went a little bit long. It was worth it. I get to end the day. Like a champion. Like a goddamn champion. I'm swearing a lot in this session because a lot of feelings are bubbling up inside of me. A lot of pain and triumph, and it's very dramatic. That's why I'm swearing so much. Okay, that's it. I'm gonna stop it right there. Stop it right after the victory point. Victory, 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 victory for you and me.